I'm Dr. Binu. In IoT sensors and devices, the third topic in the first unit is resistive sensors. Resistive sensors are devices that change their resistance in response to changes in the physical quantity. They are normally used to measure various parameters like temperature, pressure, displacement, and humidity. What is the principle of operation of resistive sensors? The operation of resistive sensors is based on the principle that the resistance of a material changes with variation in physical quantity. How it will measure the resistance means the change in resistance can be measured using a simple electrical circuit. Often it is called as a voltage divider or Wheatstone bridge to convert the resistance change into a voltage change that can be easily measured. Some of the types of resistive sensors are thermistors. It is used to measure temperature changes. These sensors have a resistance that varies significantly with temperature. Second one is strain gauges, which measure force, pressure, or mechanical stress. The resistance of the strain gauge changes when it is deformed. Third one is potentiometer, which measure angular or linear displacement. The resistance changes the wiper movements along the resistive line. Fourth one is humidity sensor. Some humidity sensor use resistive materials that change the resistance based on the moisture content in the air. Applications of resistive sensors are they are normally used in weather stations and HVAC systems to monitor temperature and humidity. In automotive field, which is used to measure various parameters like throttle position and air intake temperature. In industrial field, which is normally used in machinery to monitor stress and deformation. Advantages as well as drawbacks of resistive sensors. Resistive sensors have several advantages, which is very simple in design and easy to interface with electronic circuits. Second one is cost effectiveness, that is, which is generally inexpensive compared to other type of sensors. Drawbacks. First one is sensitive to environmental factor. The performance can be affected by environmental conditions such as temperature and humidity. The second drawback is non-linear response. Some of the resistive sensors may have a non-linear response which requires calibration or compensation in the measurement system. Resistive sensors are versatile and widely used across various fields due to their simplicity and effectiveness in measuring different physical quantities. The appearance of resistive sensor as well as the working is represented in the diagram. Resistance temperature sensor, which is simply called as RTD. The change in temperature is detected by the change in resistance of the wire. There are two types of RTDs are available. Positive thermal coefficients of resistivity uh, as well as negative thermal coefficients of resistivity. RTDs are used for temperature measurement by using them in bridge circuit. The change in temperature causes considerable resistance change, which gives a voltage drop in accordance with the thermal coefficient of a resistance of the wire. This voltage is amplified and the temperature is measured. How, this diagram represents how the RTDs are used in circuits, assisting in automatic control and measurement with a high accuracy. Design of RTD is represented in this diagram. The RTD in probe form is represented in this diagram. Some of the resistance material used for RTDs are platinum, which is the popular as well as more accurate, then nickel, copper, Falco, as well as tungsten. Why platinum is mostly used in RTDs? RTD wire is a pure material, typically platinum. The material has an accurate resistance as well as temperature relationship, which is used to provide an indication of temperature. RTD elements are easily breakable. They are often housed in protective probes. Advantages of RTDs are due to no fluid present, absolute temperature is recorded. It is highly sensitive because of that gives accurate results. It has a good range of temperature measurement. It can just measure from very low to very high temperature. Due to electrical output, it can be used with PLCs and complete automation can be achieved. Some of the applications of RTDs are it is widely used in furnaces for automatic temperature measurement. Second one is due to its compactness, it replaces conventional thermometers as well as thermocouples, thus eliminating use of lot of wires. Third one is which is used in medical and chemical laboratories to detect very low temperatures like dry ice and liquid nitrogen. Fourth point is due to electrical output, it is used wherever feedback system is required and corrective action is thus taken in an automated system. Thank you.